Hi, everyone. My name is George Airhorn, and I'm the Senior Director of Product and Platform Trust at Autodesk. My team's focus on the journey that code takes from the developer desktop to the customer use case, trying to add security and trust to that with the goal of delivering trusted products to you. Today, Gus and I are going to talk to you about how Autodesk builds trust into our cloud-based solutions and how you can do the same. I want to first start by building a shared understanding of trust. Trust is not a word that I've used to describe my profession up until a couple of years ago. So I want to level set so that we're all understanding the same thing. Next, I'm going to give you a little bit of an understanding of Autodesk's approach to trust so you can understand how we're securing the services that you use. Finally, I'm going to turn it over to Gus, where he's going to give you some practitioner takeaways that you can use when you're composing solutions with Autodesk platform. So to start with the definition of trust, I took the easy way out and just went to the Autodesk Trust Center and copied it, right? So this is what we think trust is. And I'm going to save you the trouble of picking out the important parts and highlight it for you. Fundamentally, you can think about trust at Autodesk as the combination of security, resiliency, and privacy. Also, we consider trusted AI to be part of that. But today, as I talk about how you can engineer these aspects into your solutions, I'm going to focus on security, resiliency, and privacy. Now, I think that most people know what these terms are, but I want to, again, just level set on definitions so that we can understand each other as we get into the content. So security answers questions about data. And there's two things that I think about when I think about data, and it's who's allowed to read it and who's allowed to change it. And security wonks like me will use jargon like confidentiality and integrity, but you can think about it like read protections and write protections. There are certain types of data like salary data, personal data, where you don't want people to be able to read it unless they're authorized. There's other types of data where you obviously want people to read it. How much do things cost on Amazon.com? What titles are available on Netflix? There's contrariwise, there's other information where you want to control who can change it. So certainly you want people to be able to read the prices off of Amazon, but only a select few people can be able to change the prices for Amazon. That would be bad if anyone could change the prices. So security, just think about read and write. Resiliency. Now, resiliency is beyond what conventional definitions of uptime are. Resiliency, we follow a structured risk assessment framework where we understand an application's dependencies, countermeasures, and design against common failure modes. We measure availability in terms of system uptime and engineering response commitments for when the adverse happens, how quickly can we get a team responding to it, or can we build self-recovering systems? Lastly, when we think about resiliency, I want you to think about access to the data, right? The recovery point and the recovery time objective. If we have a situation where there's a technology error, we don't want to have data that's gone forever, right? We also don't want to have people waiting for their data to come back up. As such, we do exercises to build recovery operations and test to ensure that we're able to meet our resiliency objectives. Lastly, I'm going to talk to you a little bit about privacy. And I'll admit that privacy is not my main area of expertise. I'm much more of a security person. But privacy, I tend to think about it as how can I use security techniques to achieve my privacy objectives? Those privacy objectives, I need help from the privacy people at Autodesk, the attorneys at Autodesk. I'm sure that you have those people in your organizations, but they're able to describe to us, the privacy principles. And I'm sure that you're familiar with these, right? Because there's sort of a global bend towards privacy. I guess maybe United States not as much. But the two takeaways that I want to have in terms of how Autodesk approaches this is one, privacy by design standards, and two, system-specific implementation through a privacy impact assessment. Foundationally, this means that when teams are engineering solutions, they're looking at these privacy principles to say, as I develop it, how do I make sure that I'm only going to be using data for the purposes it was collected, or that people have choices on how they're doing it, on how their data is being used? The privacy impact assessment is a structured way where we can gather data and add it to our inventory so that we understand the risks and the appropriate countermeasures. So let's move a little bit. Now that we understand what trust means, let's talk a little bit about Autodesk's approach to trust. I'm going to start with a simplified view of the software supply chain. Next, I'm going to cover some of the testing techniques and tools that we use. I'm also going to talk a little bit about the challenges that we and I'm sure you face between balancing automation and expert engagement. Now, I promise you, I'm going to give you a simpler diagram on the next slide, but I wanted to show you this. And this diagram reminds me of this guy that I used to work with named Ken. And I'm sure that you've worked with someone like Ken. Ken, very friendly guy, affable, good to see him in the hallway. But he would always ask me, George, are we secure? Are we secure? And I didn't really know how to answer that question because it made me ask questions like against what or compared to what? Because it's not really a definitive thing, right? Security is relative to your objectives or relative to a specific threat scenario. Diagrams like this allow people like Gus and I to get very specific about what specific scenario are we worried about. This lets us understand, at an abstract level, the source threats and build threats that go through our software supply chain and talk about, are we worried about a package being changed after it's being built, while it's being built, a counterfeit package being injected through dependency confusion? All of these are different things. And if you want to get specific about how you're protected against it, you need to decompose your architecture into something like this and then look at your supply chain from a trust perspective. So, for people whose trust and security is their full-time job, that last diagram is very good. For the purpose of this, I want to break it down a little bit simpler. I want you to think about the way that you can do trust at the source, the build and deploy, and the runtime perspectives. Source is things that you know about, like GitHub, Bitbucket, your source code repositories. This is where you're also going to be thinking about your artifact repositories like Artifactory, your npm repository, container libraries, and stuff like that. Build and deploy, right? This is your DevOps infrastructure that takes source and makes it usable for someone. So common tools here would be Jenkins, CircleCI, Spinnaker, GitHub Actions, stuff like that. In the runtime, this is interesting, right? In the last diagram, we were only talking about source and build, but now since we're talking about cloud applications, once you deploy it to a runtime, there we have the ability to use cloud native services for trust objectives as well as hardened infrastructure to, move those protections to where there are, real-time adversarial presence. So I'm going to go over the source, the build and deploy, and the runtime. I don't want to go into detail because really Gus has the information that's a better takeaway for you. But I wanted to give you a little bit extra detail about how we implement this. The two most important things that I wanted to talk to you about for source protection is branch protection and software composition analysis. Branch protection is really low-hanging fruit in terms of implementing policies on who can merge to main. Are you allowed to merge without a comment? Are you allowed to have a pull request without, just simple, GitHub or branch protection policies that control your release and control the composition of your software. Speaking of software composition, Source is also a really good opportunity to do software composition analysis to understand your third-party component risk. So, you cannot build software without open source software, right? You can a little bit, but not at the scale that we're talking about. Using open source software adds risk, right? It just does. So understanding the vulnerabilities in those third-party software and how they impact us is something that we can look at the source protections, looking at manifest files or looking at libraries that are used by the different components. So build and deploy, there's really two things that I want you to take away here. Build and deploy is a really good opportunity to record and verify provenance. Now, again, 5 years ago, I wouldn't have said that my job was trust. Also, 5 years ago, I didn't know what the word provenance meant, right? But provenance is how do you know where your software artifacts came from? The easy example is from the art world, right? If you want to buy a painting, you want to make sure that in the history of that painting, it has never been stolen, right? You're not gathering illicit goods. If you have software, you want to know, where did those software components, where did those software artifacts come from? Also, at the build and deploy step is where we can do pre-deployment validations. This is things where we can implement signing policies, ensure that we're establishing artifact provenance, and do pre-deployment checks against standards for infrastructure as code or container security standards. Lastly, I want to talk to you about runtime protections. And this is, again, certainly adversarial users exist, in the source and the build and deploy, but in terms of the attack surface, runtime is where you get, exponentially larger. So here, the two things that I want you to take away here is there's a good opportunity to monitor threat intelligence, right? Now that you are exposed to authorized users and exposed to unauthorized users, the telemetry that goes through your applications, the log data, the IPs that it's connecting with, the URLs that it's trying to access, all can give you information about the current state threat scenario of your application. So we use feeds from various partners to understand, is the information that we're seeing indicative of a problem? Also at runtime, this is where we have the opportunity to look at things like chained attack paths. So in the context of, there's a hacker who wants to do something, sometimes the sum is worse than the component parts, right? So if A is true, that's bad. And if B is true, that's bad. And if C is true, that's bad. But if A and B and C is true, that's cataclysmically bad. So we're able to use advanced tooling to understand whether or not the combination of certain configurations expose us to a risk that's untenable. Lastly, I want to talk to you about prioritization. Now, I want you to think about, right, the worst case scenario versus the most likely scenario. So this is an AI generated images of Airbus A380s, and there's 40 of them. Now, 555 people can fit on an Airbus A380. So what I want you to think about in terms of the vulnerability world is there are as many vulnerabilities discovered in a year as there are people on these airplanes. So if I told you, hey, everyone, over the next year, 40 airliners full of dangerous criminals are coming to your town, that would be bad, right? You would be very concerned about this. But this is the problem about the worst case scenario versus the most likely scenario. In the vulnerability world, when information comes out, they want you to understand what is the worst case scenario, but that is infrequently the most likely scenario. So it's one thing to have a software with a bug in it. It's another thing to have a software and a bug in it that an adversary can exploit to their gain. To put it in the context of this picture about airplanes, if you take all of the people and say, well, actually, they're not all dangerous criminals. They all have the capacity to steal something, but only 120 of them are actually criminals. That's fewer than the right-hand window on one of these airplanes. So trying to figure out which of these are dangerous and which of these are not is really a challenge. There are a couple things that we do to help us here. I mentioned threat intelligence before, but here's also where we can use techniques like attack paths and reachability, right? The context matters here a lot. When these bugs get discovered, sometimes they're only true under certain conditions. If we can look at how we're using components or how code travels through, the path, we can understand whether or not that specific scenario applies to us or not. And that's how we can use this to understand where we can focus our efforts, because automation can solve and discover a lot of things, but sometimes you need a human being to help you understand what that means and how you should react. So I thank you for your time listening to me talk about how Autodesk does things. Now I want to turn it over to Gus, and he's going to explain to you how you can apply some of these techniques in your use of Autodesk platform. Thank you.
Hi, I'm Gus Tabares, Senior Manager of the Application Security Team at Autodesk. My team is responsible for ensuring that Autodesk applications are designed, developed, and maintained securely. Our main goal is to identify and reduce security risks in our products throughout the software development lifecycle. So today I'm going to cover a basic APS workflow and how you can incorporate some of the principles that George discussed into your APS usage. So I'd like to start with describing a simple use case of using APS Webhooks API. And for those of you not familiar with the Webhooks API, essentially it allows applications to subscribe to APS events. For example, when a Revit Cloud work sharing model starts synchronizing, or when there is a data management event, like when an item is modified or deleted. Whenever the event occurs, the application will receive a webhook notification to some callback URL that is specified when configuring the webhook. Webhooks in general, for those of you who don't know, are a good way for applications to communicate with each other automatically in real time. So instead of one system needing to constantly check or pull another for updates, a webhook allows the source system to send data immediately to a URL that when a specific event occurs, very similar to a push notification on your mobile phone. So the workflow I'll be showing is put simply into three main steps. I'm going to go through it in code, specifically Python code, because I like Python. First, I'll show how to get an APS token using your client secret. After we have our token, I'll show how we can call the Webhook API to register our callback URL and our Webhook event. And then I'll show what it looks like to receive an actual event from the API and to parse the message. Now, while I'm going through the next 3 to 4 slides, I'll ask that you think about what kind of things are we doing that are wrong so that we can do them in a more security-focused workflow later. Hopefully, some of the things are really obvious, while perhaps some others are not. So in this slide, I have some simple 4-line Python code that goes out and gets an APS token and prints it out when we get it. We have a function called getAPSToken that you'll see in the next slide, which takes a client user ID and a client secret as input and returns the token. And later on, we'll use this token to create the actual webhook itself. So here we have the actual definition of our getAPSToken function. It calls the authenticate API using basic HTTP authentication. Now, for the sake of simplicity, I'm using a 2-legged token as opposed to a 3-legged token. So after calling the post endpoint that you see here in the response equals line, it parses the response for the actual token and returns it to the caller. Now, as a reminder, we're only going to use this token to register our webhook and nothing else. So I'd like you to take a look at specifically the scope that we're doing here and whether you think that this is the right scope that we should be doing for creating a webhook or not. So now here we have our function call create webhook, which does the actual webhook creation. It adds a new data management event, specifically the DM version added event, which triggers when a new file is added to a folder. Now we have a few parameters to this function, first being our access token, which will be passed from the output of our getAPSToken function in the previous slide. The other is a folder URN, which specifies which folder we want to monitor. And then finally, we have our webhook URL, which is the URL that will be called when an event is actually triggered. Now we're not showing you here, but you can assume that we've called the create webhook function with our access token from the previous slide. We have our folder URN, and we have some URL that we own to create the webhook. So now here we've created a function that will monitor and listen to some events. We've created a really basic Flask listener on our fictional/webhook API, which is listening to some post events, which are essentially what gets sent from the webhooks API itself. For the sake of simplicity here, we're taking the incoming message and simply returning it to the caller. In any actual application scenario, you'd want to do something a bit more useful, like trigger an email or perhaps perform some other useful APS functions specific to data management. Now, I'll just give you a second here to take a look just to see if anything kind of pops out to you or not. All right, now what I'd like to do is take that same workflow and upgrade it a bit with some security considerations in mind. We still have 3 steps as before, but in each step, I'm going to modify it a little bit to be more secure. And we're going to look at 3 specific things. The first is using a secret store. The second is scoping our tokens to only access what we need. And then finally, verifying the webhook message to make sure that it's authentic and actually coming from Autodesk as we expect. So first, we'll go back to creating our APS token, but this time, instead of hard coding our password in the source code, we're going to pull the secret from a secrets manager, specifically AWS Secrets Manager. Here we have a function called getAPSClientSecret, which takes a secret name string and a region as input. and it will securely fetch the secret from Secrets Manager and return it as a string. Here we have the definition of our get APS client secret. It uses Boto3. Boto3 is a Python library for interfacing with AWS services. And you can see here, it takes our secret name string. It goes out to AWS Secrets Manager and pulls it and returns it as a response. So just a note here about secrets in general. Your API secrets are your keys to the kingdom, right? You don't want to be putting these keys under your doormat, or even worse, in a public GitHub repository. You also want to make sure that if you're sending these secrets to others, you don't want to send them in an insecure method like plain text email. AWS Secrets Manager or something like HashiCorp Vault provide a unified interface to access secrets while offering tight access control and audit logs. Also, both provide a mechanism for auto-rotating credentials, which in conjunction with APS API calls for rotating your keys, you can do it in an automated fashion and on a scheduled basis. So the takeaway here being, please don't hardcode your secrets in source files. This is something that we tend to see often with APS users, and they upload it to GitHub, and we have to go out and essentially rotate it for them. So here we're going to revisit the get APS token function again, but this time we're going to reduce the scope of the token to the access that we need to perform the function, which in this case is just creating the webhook. Now, in the security world, we always try to follow what's called the principle of least privilege, which essentially means you've given access to do essentially what you need and not anything more. So as an example, if someone is cleaning an office building, they should get a key to the room or rooms they're cleaning, not the keys to the entire building. In the context of APS, if you only need to view, say, a particular model, then you should scope the access token to that specific model and nothing more. So that way, if the token is ever stolen or compromised, the damage is limited because the attacker can only gain access to what the token was scoped to and not the entire system. So here you can see we have the scope set to data read, data write. These are the specific permissions needed to be able to create a webhook token. Previously, you may have noticed we had a whole bunch of different scoped items for creating buckets and all these things that essentially weren't required. So we've scoped that down. Here we have our create webhook function again. I'm just showing it here for just to remind you, we're not going to make changes to this function in particular, but what we're going to do is we're going to use that same code, but what we're going to do is we're going to add an extra call to set a webhook secret. This secret is going to be used to compute an HMAC. Now, for people who don't know what an HMAC is, it stands for hash-based message authentication code. It is a cryptographic technique used to verify the integrity and authenticity of a message. And the way it works is by taking some secret or some token and combining that with a message payload to generate a one-way hash. So only someone with the secret key can compute the correct hash value. So in order for this to function, both the sender and the receiver must know the secret key. So in this case, the sender being APS itself and the receiver being us, our application. So here you see we have a set webhook secret call. It takes our access token that was created in the previous slide, and we have some webhook secret, right? And it calls the webhooks v1 tokens call, and it sets that secret for our webhook. And now finally, we're going to go back to our code, which receives the event from APS, except this time we're going to compute the HMAC and verify it. So we get our webhook secret using our function that pulls from AWS Secrets Manager from earlier, because again, we don't want to be storing secrets in our source code. So we store our webhook secret in AWS Secrets Manager. We pull the signature from the xADSK signature HTTP header, which contains the signature of that message. We take the message, we combine it with the secret, and we compute what we expect the signature to be using a SHA-1 hash function, which you see here on the expected signature line. If we compare these two values and they match, then we can safely assume that this message is actually coming from Autodesk and not from some rogue malicious actor, or that the message was not tampered with along the way. The takeaway here is like we cannot assume that messages coming into us are from who we expect them to be, and we need to verify and ensure that we have message integrity and authenticity. And the way we do that here using Webhooks API is to set a secret and to compare that HMAC. Now I'm going to turn it over to George, who will give us some closing remarks.
Gus, that was very informative. And I wanted to bring back our shared understanding of trust and now highlight not the component parts, but the top. The trust is earned not in a moment, but across thousands of interactions over time. And this is one of those moments. And I've really appreciated the opportunity to talk to you a little bit today about how Autodesk approaches trust and how you can do the same. I want you have a couple of takeaways. One is trust is more than the sum of its parts, right? We can talk about security, we can talk about privacy, we can talk about resiliency, but when we put them together, that's how we talk about, building a trusted platform that helps customers complete their use cases. As you think about how to apply these techniques within your own worlds, look for low-hanging fruits in your source protections, your DevOps protections, and your runtime contexts. Think like a hacker, right? A lot of developers are good at use cases. Teach them how to think about abuse cases, right? Imagine that adversarial persona out there and what they're going to try to do. And then think about what Gus said, right? That is a pretty repeatable workflow when you're using Autodesk Platform Services. Use a secret store to protect your secrets, limit your privileges to what you need, and then validate your message authenticity and integrity. I think you'll be a little bit more trustworthy for it. Thanks very much.